So we formulated the sequence for the invariant preservation for the two new events in the refinements. Let's now try to prove them if they are provable. So the first one to really prove would be for the ILN, and with respect to concrete invariance number 4, which is about the total number of A, B, C, and also N. Of course, now we need to worry about the post-state substitution as well, as you can see over here. Right? If you got any doubts about how to formulate this particular sequence, you can refer to the earlier part of the lecture. Right? Let's see how we can prove this. And I would say I'll give you 2 chances to really try to prove it by yourself before you compare your answer with mine. So I would say with this already, can you actually try to make use of the relevant inference rule from the 2 example sets that we spoke about earlier? Right? So you can see which one might be relevant to prove this one. This one you will see is rather easy compared with the other one. All right, you can now pause the video and think about the proof. All right, assuming that you thought about it, let's now take a look at with some hints over here. That's the sequence we want to prove, and it turns out you only need monotonicity and also the hypothesis inference rule. These are the only 2 you will need. All right, and if you want to pause the video and try yourself again with the hints, of course, please go ahead. Alrighty, so let's now go over my answer and compare with yours. And I would say I'll give you the consistent advice. If you're given so many hypotheses to actually start with, you definitely want to see which ones might be relevant to the goal over here, right? So the goal is really to do with A prime plus B prime plus C prime is equal to N prime, something to do with that, right? So now you want to see which hypothesis can actually help you with that. And I would say this one seems to be, that seems to be the pre-states satisfaction for the concrete invariance, right, in the pre-states. In that case, this one should definitely be kept over here. Would this be enough? Actually, it turns out this will be enough, because if you try to do some simple arithmetic, -1 plus 1 cancel out. You got exactly A plus B plus C equals N. In that case, you got exactly this appears in both the hypothesis and the goal, which will be proved without any modification according to the hypothesis rule, right? You can see this one is rather straightforward. You just have to observe in so many hypotheses to see which one might be relevant. And in this one, we are lucky. It's rather straightforward. Okay, let's now complete the proof. Enough about the insight. Right, so what we're going to do is we're going to make use of this hypothesis only. That's all we're going to keep. Everything else will be dropped. So I'm going to say by the monotonicity, what we're going to keep will be, we're going to keep only A plus B plus C equals N. So that'll be the pre-state satisfaction for the abstract invariance. Concrete invariance, beg your pardon. And then that should entail this goal over here, which should still be there, right? So only with monotonicity, you cannot really simplify this expression any further. You need to apply maybe the ARI arithmetic rule in order to do it. So let's do one step at a time. So this will be A minus 1 plus B plus 1 plus C equals N. And so this will be after dropping all the irrelevant hypotheses, right? I'm pretty sure I can draw the box better. Let's now do it. Right, so after this, what should we do? Well, we cannot really apply the hypothesis just yet, because you can see this form over here is not exactly this, even though they're equivalents. But they're equivalent, but it's not enough in order for you to apply the inference rule. Here, P and P must be exactly the same, verbatim. Even though they are logically equivalent, you can see A plus B plus C and this expression here, even though they're equivalent, but you just cannot use the hypothesis, right? It's a common mistake people might make, right? So what we're going to do is we're going to apply another rule over here, which will be about arithmetic over here. So what will we get? What we'll get is A plus B plus C equals N. This is not the one we want to simplify. We wanted to simplify this expression over here. Right, you can see here, if you try to simplify it, -1 plus 1 cancel out. So that will be A plus B plus C equals N. This will be matching the hypothesis indeed. This will be good. Right, so this one here, you can see P over here, exactly P. Right, so this is P matching exactly hypothesis. That's good. And we can now conclude that this sequence will be proved automatically without any further justification using this axiom inference rule. Right, so that's about the first one, rather straightforward. And let's now move on to the second one.